The Earth, a giant hunk of rock and water that's home to the only known life in the universe. It's so vast and old that it seems unchanging, yet it has in fact experienced cataclysmic upheavals and routine facelifts over the course of its 4.5 billion year lifespan. Just like a human being, the Earth ages, and as it does, it goes through major changes. Hello and welcome to another episode of the Infographics Show. Today we're taking a look at the most important events in the Earth's history. 4.5 billion years ago, the Earth and most of the solar system was nothing more than a ring of protoplanetary dust circling the Sun. However, over time, gravity gradually drew individual particles of dust together, creating ever larger clumps. Eventually, the clumps grew to the size of boulders, then to the size of mountains, and over many millions of years, the Earth was formed. Yet this newborn Earth was nothing like what you see today, with little if any water and a surface that was perpetually molten. Over millions of years, the outer layer cooled, however, to form a crust, and planetary impacts of comets and asteroids brought all the water that you see today to the Earth from space. Not long after the Earth's creation, it's thought that gravity put it on a collision course with another nascent planet, roughly the size of Mars. This planet, named Theia, slammed into the Earth with 100 million times more energy than the impact that wiped out the dinosaurs and hurled vaporized chunks of both bodies out into space. Gravity eventually bound the ejecta together and created our moon. This impact gave our planet the tilt it has today, which in turn gives us our 4 seasons and helped stabilize its spin, two things which scientists believe were critical for the evolution of advanced life. Sometime between 4 and 3.5 billion years ago, the first organisms evolved on the Earth. Scientists aren't exactly sure on when this occurred, as the oldest confirmed fossils of single-celled microorganisms are 3.5 billion years old, but there could be undiscovered older fossils waiting to be dug up. What scientists do know is that life evolved almost as soon as it possibly could, immediately after the heavy bombardment stage of our Earth's evolution, when it was being periodically slammed by huge asteroids and comets. This gives many scientists hope that life is actually abundant in the universe, and not just here on Earth. It's believed that the first life on Earth used chemical reactions to power itself, but it wasn't long after it first appeared, perhaps just as short as 100 million years, that microorganisms evolved to use sunlight for energy. By capturing rays of sunshine, these microorganisms were able to make sugars from simple molecules, a vastly more efficient means of providing energy than the chemical reactions employed by their ancestors. Photosynthesis and the unlocking of exponentially greater energy potential in organisms may have been the key to life's diversity. About 3.5 to 3.2 billion years ago, the first continents began to form and plate tectonics began in earnest. Before this, it's thought that giant plumes of very hot magma shot new material straight up to the surface and began to build land masses. But as heat-generating radioactive elements began to run low in the Earth's interior, the mantle began to cool, and less of these super plumes were created. This allowed convection cells to become stable in the mantle and start driving the movements of huge continental plates. If you like breathing oxygen, and we suspect you do, then you should be grateful to tiny little bacteria that existed 2.4 billion years ago. For half of the Earth's life, there was very little oxygen in the atmosphere, but then suddenly some bacteria evolved to use photosynthesis to make sugar from carbon dioxide and water, much the same way as plants today. This was a huge leap forward in evolution, as before then, photosynthesizing microbes did not release oxygen as a waste product, known as the Great Oxidation Event. This turning point in Earth's history is also known as the Great Oxygen Catastrophe, because the introduction of this volatile gas was toxic for most pre-existing life. These tiny oxygen-producing microbes would go on to kill almost all life on Earth as a consequence. Around 1.2 billion years ago, life took another significant leap forward when two microbes got together, put on some slow jazz music, dimmed the lights, and invented sex. Scientists don't know why organisms simply stopped dividing in two to reproduce, but they discovered fossils of red algae, which are thought to be the first organisms to develop specialized sex cells. In their case, spores indicate the change was relatively sudden. Shortly after the invention of sex, life took its most significant leap forward, developing the first multicellular organisms about 1 billion years ago. Up until then, life had consisted solely of single-celled organisms living living individually or in colonies, but now cells were working together to form complex life and creating things like mouths, limbs, and sensory organs. Plants would beat animals to the punch though and secure a foothold in this brave new world first. Another mystery of science, the Cambrian explosion, took place 535 million years ago and gave us almost every group of modern animals alive today. Animals exploded in a variety of sizes and shapes and filled every available niche both on the seafloor and in the water column. This explosion of animal life also saw the evolution of the first predators and launched the predator-prey arms race of weapons and defenses that persists to this day. Towards the end of the Cambrian explosion, about 465 million years ago, plants began to venture onto the land. Descendants of green algae, plants quickly diversified into the descendants of today's modern plant life. Animals also made the trek to land, but only briefly, most likely to lay eggs somewhere without predators. However, these brief forays in the expansion of plant life on land led animals to begin to evolve to exist on land. The first plant eaters were quickly followed by their predators. About 460 to 430 million years ago, though, things took a turn for the worse for Earth's budding animal and plant life. Though life had exploded during the Ordovician period, towards the end, the planet began to cool and ice sheets spread out from the poles. 85% of all marine species were wiped out, and fish became much more common as a result. Evolving from newt-like amphibians, the first reptiles appeared around 320 million years ago in the middle of the late Paleozoic Ice Age. Unlike their amphibian ancestors, though, reptiles had tough, scaly skin and laid eggs with hard shells. These evolutionary adaptations allowed them to leave their amphibious lifestyle behind and begin the colonization of the Earth, eventually leading to the age of the dinosaurs. Before dinosaurs could arrive on the scene, though, the Earth threw a particularly violent temper tantrum, lasting millions of years, and exploded with volcanic activity. Toxic gases in the atmosphere led to the acidification of the oceans, killing up to 96% of all marine species and almost all land animals as well. Despite being nearly wiped out, again, life would bounce back, and in the aftermath of what is known as the Great Dying, the first dinosaurs evolved. As dinosaurs began to rule the Earth 220 million years ago, a small group of them took a different evolutionary path, descending from small reptiles called cynodonts. With faces like dogs and possibly even having fur or whiskers, the first mammals were the size of a shrew and were almost certainly only active at night so they could avoid being easy meals for their dinosaur overlords. Their nocturnal lifestyle may have led to their warm-bloodedness and the ability to keep their body temperature constant regardless of the environmental temperature, a key adaptation for surviving a future catastrophe. 65 million years ago, a giant asteroid larger than Mount Everest smashed into modern-day Mexico. The asteroid was so huge that just the tip was touching the surface of the Earth. Its uppermost edge was still high up in the atmosphere. The initial explosion devastated a large area of the Earth and created tsunamis that wiped out coastal areas. As debris from the explosion was hurled up into space and re-entered the atmosphere on the other side of the Earth, it set off huge forest fires around the world. Dust thrown into the upper atmosphere would block out sunlight and bring about a miniature and sudden ice age that would be the fifth and last mass extinction on our planet. You probably didn't know, but the first mammals were actually egg layers, just like their reptile brethren. In the aftermath of the global extinction event that killed off the dinosaurs, though, many mammals began to nourish their young inside their womb, which was safer than laying eggs in a cold, hostile world. About 60 to 55 million years ago, some of these early mammals evolved into the very first primates, who would eventually give rise to modern apes, monkeys, and, of course, humans. The first true apes appeared in Africa about 25 million years ago. Then suddenly, about 13 to 7 million years ago, the ape family split into the ancestors of modern humans and the ancestors of modern apes. The oldest known hominid was Sahelanthropus tradensis and lived about 7 million years ago. Hominids proved to be so successful that their evolution continued down through the ages, until finally 200,000 years ago we appeared on the scene, irrevocably changing the Earth forever. Our Earth has a long and storied history of death, rebirth, and constant change. It might seem static and unchanging to us with our short lifespans, but we've only existed for a blink of the eye in terms of planetary history, and the process that shaped our world and the species within it are constant and incessant, working every single day to create a new future. For the first time in the Earth's history, though, what that future may look like is largely dependent on one of its own species, and as we face the threats of global warming and ever more destructive wars, we will be largely responsible for our own survival survival or extinction in a way no other species has ever been. If you could have been alive to see any event in Earth's history, which would it be? What will the future of Earth look like? Also, be sure to check out our other video, Days That Changed Mankind Forever. Thanks for watching, and as always, don't forget to like, share, and subscribe. We'll see you next time.